Okay, so I want to make some clusters of constraints kind of at the top. So we have some big chunks of the building that fall and smaller bits kind of fall apart around it, right? So just after here, I think, yeah. If we come here, I'm going to come out and drop another delete. Let me, I'll name this delete section. Okay, and then get this other delete. So I'm going to use this as a location for the points of where to place these clumps, okay? These kind of clusters, I suppose. So here I'm going to set this to points and delete non-selected, and then we're going to do it by position. So at p dot y, because I want them, you know, up high is bigger than 80. Right, so that will give me points at the top of the building, and then I'm going to scatter over these primitives. Okay, and obviously, you know, I don't want loads, all of these points. I just want a few, so I'm just going to do 5. And then let's do a copy to points. So points in there and sphere into the left. Okay. And with the sphere, set this polygon, set the frequency to 10. Okay, let's visualize that. So obviously we need some scaling here. So attribute randomize. Again, with the randomize, we'll look at the, let's see, what's the global seed, just so we've all got the same, 5449 in there. Okay, and then we want to change the P scale and the distribution. Let's see. Yeah, it's going to be one dimensional again. I don't think we changed the other one, but it doesn't really matter because it knows, you know, this is a known value. From 1 to 10, do something like that. Okay, and then if we template the building, we'll see. So this is where our, you know, these will be our big kind of chunks, and then we could play around with this placement by playing around with the global seed to set that to 0. I mean, that looks fine to me. Okay, and then to make the pieces a bit more interesting, let's drop a mountain down here and scale this up. Scale the shape so they're a bit more kind of lumpy again. And then what we'll need to do is use these to create groups on our constraints, right? So down here. So doing all of this, and then we'll feed it back in again. So we'll make a group. It will have to be on the points. Normally everything on the primitives with constraints, but when you make a group from input geometry, it has to be on the points. So we will create, this will be, we'll call it clumps. We will need bounding regions, bounding, not sphere, sorry, bounding object. And there we go. We can see we made that selection. And then we'll need this onto the primitives, this group. So if we do group promote there, plug that in. So this will be clumps, and it will be from points to primitives. Okay, so you can see there now we've got our prim group clumps, and then this will just merge back, not merge, but this will be our constraint stream now. And then I'll do it down here. We could do it anywhere really, but I'll do it down here anyway because we're generating, no, it needs to be after this actually, because I want to make those clumps have stronger constraints basically. So we grab that clumps group, set this to primitives, and let's multiply that strength. So F, let's grab that, F at strength times equals 100. So that means strong clumps. Okay, so let's see, if we go in here, oops, I don't want to make a font. Go in here and then onto our primitives, we'll have a strength attribute at some points. there. So yeah, in the clumps, the strength will be 500,000 and the others will be 5,000. Okay, so quite a substantial difference, and enough for the clumps to hold in pieces as they fall to the ground, right? So just press Alt and click to put these kind of elbow things to make some space there around it, just to make it look a little bit neater. So as I said previously, I think it's good to play around with these shapes, just to get different results. And what I found was using the box just kind of made the whole building a bit less stable, so that allows the top to fall down. It should anyway. Fingers crossed, right? So what we'll do, we'll cache it out. I'm going to change that to box. Okay. When you're checking your geometry shapes, when you've got a bit of a heavier sim like this, it's kind of a weird thing. I'm not really sure why, but if you visualize it at this context, okay, in this geometry context, it seems to take a really long time and run really slowly and crash Houdini often. So what I do often is set this to manual, go into show geometry, turn that on, show geometry representation, dive inside here, and then set that to auto update, and then I get that pretty quickly there. So you can see that, obviously it's not perfect. We've got boxes overlapping everywhere. I think because of that, it's, kind of inherently unstable and kind of pushing themselves apart. But I found that the sim, came out nice in the end. So again, set that to manual, turn that off, auto update. Save it. You can try it on yours, see if it works, but I can't be bothered with Houdini crashing. It's annoying. So I'm also going to make the global animation. I want a longer sim, right? So I'm going to push this to 350 to give the building time to collapse. Because in all of those flip books there, it didn't have time to. I know we just did 200, but still. And the top didn't fall, but still, you could tell we needed quite a bit more time. So let's cache this out, RBDIO. So we need our geometry and our points, simulation points, okay. So what this will do is just cache the actual points and apply that transform from these points to the static render geometry here, okay. So we set that up by changing this to geometry and points, and then we save the geometry here. So that's just a rest. You can see there's rest, and we don't have. You can see by default they got $F up here, which means they're saving every frame. For the simulation here, they are not. Okay, it's just the one frame. So let's save this in sim, not in geo. I think there is a sim folder. I'm not sure. If not, we'll make one. Yeah, there's one there. Okay, so sim, and then let's make another folder for the concrete. / concrete dot rest. Again, don't put $F, just Bagio is fine. And then I'll just copy that, paste it up here, and get rid of rest and put $F 3. Okay, and then we'll save that. So we'll just save that one. That first frame, and then when we save this, it will save the full 135 frames. So let me just save this scene and then save that, and fingers crossed we get a nice sim. Right, so that simulation is finished. Didn't take too long, 10-20 minutes or so, something like that, for 350 frames. That's not bad. So let's see how that went. It's cool so far. It's really nice, that kind of wave bringing down, and then these bits falling, and then we get this nice big piece falling at the end there. Brilliant. So one thing I think I'll leave it, but one thing you might want to do, you might find that this is taking too long to fall, so I would maybe just lower the glue strength if you like. I'm going to leave it. I kind of think it's okay. And then you notice there at the end we get these kind of big clumps at the end. So you see it's kind of holding together here, collapsing in the middle there. The back is all collapsed. So that's because of those groups that we created. So we get a really nice variation. We get lots of small pieces and then some big clumps as well. And I like that it's kind of almost like in 2 stages. We get it's like 2 simulations. We get these bits falling at the start, this kind of wave going down, and then after that the big chunk collapsing and this kind of folding forward as well, which is nice. So yeah, that's great. Next we can move on to doing the metal.